is my first time presenting this lesson, so I hope you enjoy it. Let's start. For thousands of years, people have wondered about the world around them. They wondered where things come from. Can you imagine a time before there were any cars, or schools, or grocery stores?
Yeah.
Can you imagine a time before there were any cities or homes, even before there were any people? Can you imagine even farther back in time, before the dinosaurs, before plants, before there was anything living on Earth at all? Before there was an Earth, before there was a sun? What if we go all the way back to the very first moment? A place in time where nothing happened before. No Earth, no sun, not a single star or galaxy anywhere. This is a story about these things, about how we think Earth, the sun, the stars, space, and even time begins. It must have been a very long time ago. Astronomers have studied the cosmos and determined that it was about 14 billion years ago. They learned that everything in the whole universe was once pressed together somehow in a tiny singular mass. Everything was packed together so tightly in this point that it became very hot. We think it's a hot day if it's 100 degrees outside. Can you imagine how hot 1,000,000 degrees would be? 1,000,000,000 degrees? It's hotter than even that. Now, if everything were pressed together very tightly and everything were very hot, then the things that we know couldn't exist. It was too hot and there was too much pressure. Living things couldn't possibly exist. Even the sun couldn't exist. It was too hot for stars. It was too hot for atoms. The hot point was unstable. All that matter and all that energy didn't want to be so close together. They jostled together until bang! In an instant, great energy, the whole universe was brought into being. The energy cooled enough to form particles. The particles cooled enough to form atoms, and the atoms cooled enough to form gas clouds. There's an uncountable number of these interstellar clouds, each one of them enormously big and beautiful. And in each cloud, wisps of gas huddled together, forming small droplets. The droplets got bigger, more wisps huddled together, until they were so crowded that they ignited into light, becoming a hot, hot star. Billions and billions of wisps lit up into stars. One of these stars, spinning in a galaxy of stars through an enormous space, is our sun. The sun is just one of billions of stars in the universe, like one drop in an ocean. Our sun spun, pulling a hot cloud of gas around it. And in that cloud was spinning debris, wisps of gas and tiny rocks huddled together. One of these clumps of rock would become our home, Earth. Our Earth is much smaller than the sun, but it's precious and important to us. There we are, and there's our sun.
Wow.
Over here so you can see. universe is made of tiny particles. Each one was very hot. Each was moving very fast, and they were once too hot for the sun to exist. There must be billions and billions and billions and billions and billions of these particles through the universe. And yet every single one of them behaves the very same way. How is that so? They're following laws of the universe. These laws cannot be broken. It's impossible. Every scrap of the universe, every speck that we might think too tiny to matter, every single thing follows these laws. And here are a few of them. When particles get colder, they come together. They huddle up very close, tightly packed, like you might do if you were cold. And when the particles get hotter, they can become less connected. They move farther apart, and they can move somewhere. And when the particles get even hotter, they can move even farther apart and move around freely. By becoming colder or hotter, by moving closer together or farther apart, the particles can form themselves into three states: solid, liquid, and gas.
The safety glasses.
Yep.
The glasses.
Probably don't need my glasses over my glasses. Didn't used to need glasses. Solids. They maintain their shape. Bend them. The particles in a solid hold together very tightly. Can't poke through it. Can't bend it. Solid. It takes great energy to break them apart. And even when they are broken apart, the pieces remain solid. Liquids aren't bound together quite as tightly. They will move aside when you come through them. They will take the shape of whatever container they're in. And gases spread out as far as they can. And they dissipate. They go wherever they possibly can. Gases move and fill the space. The laws of the universe also say that particles cannot be solid and liquid and gas at the same temperature. If the temperature gets hotter, some particles will become liquid. If it gets hotter, they'll become gas. These are science tongs. They're different from cooking tongs because they're used for science. I have here a 2006 penny. I have here an acetylene torch that we use to put the pipes in our house. Acetylene torches are hot. Pennies are solid. We're going to apply heat to our penny. Listen. heated the penny, the solid, and it became liquid. When I put the penny into the liquid, it heated the liquid to create gas or soccer. The young Earth was very, very, very hot. There were no solids. It was all liquid. And this ball of liquid rock that was spinning around itself and spinning around the sun, something started to happen to it. The outer surface began a dance. The particles on our hot, early Earth were next to the cold space, and they became colder. Following the law, they huddled up close together, which made them heavier, and they sank down to the Earth. But inside the Earth, it was still molten, boiling rock, and those particles heated up. This made them expand and come apart and rise to the surface towards space, which, once they got to space, they cooled down again and huddled up and fell back down, heating up and completing the circle. Up and down, around and around, over and over and over again, like a dance. Each time a hot particle rose into space, it carried some of the heat from the Earth away. Once it had given away all of its heat and it was shivering from the coldness, it would fall back to the Earth. Slowly, one particle at a time, the Earth began to cool. As the Earth cooled, inside the bubbling, boiling hot rock, materials started to organize. Some of them were heavier and sank to the bottom. Some were lighter and rose to the top. This one sinks right through the other two materials, right to the bottom.
So heavy.
It's very heavy.
What is that?
Heavy metal that sank to the center of the Earth.
That's the best answer.
So, like this, the Earth created its layers. You might have noticed, looking around, living in the world, things aren't just rocks, water, air. Other kinds of substances exist. This is because some kinds of particles are attracted to one another, and they can combine to form new substances. But not all substances can combine. I have two substances here, sugar and sand, and water. I add some of this sugar to my water. Agitate it. The sugar dissolves. It disappears. We can't see it anymore. The sugar particles didn't vanish. Instead, they've combined with the water to create something new. sand and add it to the water. Maybe if we agitate it. They do not combine. They stay separated. No amount of agitation will combine these two substances. They will not make something new. The earth cooled more and more through our cosmic dance, all the time spinning around itself and spinning around the sun. After a billion years or so, the outer surface was cooled. It was cold enough that it did become solid, like a skin over the hot stuff inside. It seemed the earth had calmed down, taken a solid shape at last. Not true. Oh, the liquid rock inside the skin was still boiling hot, and it felt trapped. It wanted to get out, and there was only one thing to do. It had to follow the laws. If you're hot, you expand and rise, even if you are molten rock. There was no room inside our solid shell of the earth, so they pushed against the skin and broke out. The whole planet was covered in volcanoes. This was the most dangerous experiment. That was real magma.
Yes, because the blowtorch wasn't dangerous enough.
Oh no, that wasn't real magma.
That was just
Unlike
fire,
our
not
volcano. The whole planet was covered in these volcanoes, these cracks in the crust where the magma burst out. It was a rather unpleasant place to be. Can you imagine what it would have been like to live on an earth like this?
Dead. You'd be dead.
Because you would be hungry and then you'd be dead.
This time,
You wouldn't be able to look too because the lava's too hot, it'll just burn your food and you'll be sad.
this time in Earth's history is called the Hadean period, after the Greek god Hades, god of the underworld. This is our sun, trying desperately to peek through. There was some water on our surface, but when the hot magma spewed out, the water would immediately boil, turn to steam, and it formed giant clouds over the earth. The ash and gases from the volcanoes added to these clouds. The whole planet was covered. The sun couldn't shine through for thousands of years while the volcanoes poured hot magma onto the surface. After a very long time, the earth cooled down into a mostly solid ball, though to this day, there's still some hot liquid rock inside. It became cool enough for the water to pool and stay liquid. And then it rained, and rained, and rained for millions of years. So much that the oceans were formed in the low places, and the lakes and rivers were formed. Above the earth, the volcanic clouds finally disappeared, and the air collected. The sun could look down on its beautiful little daughter, the earth, and see rocks and water and air, solids, liquids, gases. And even today, the earth still goes on spinning around itself, spinning around the sun, and the sun goes whirling through its galaxy, cloud of stars. And all over the universe, other galaxies still go spinning and spinning away from each other. And in the whole universe, every particle and every star in every planet, and every bit of dust still follows the same laws, just as they've been doing for 14 billion years. The story of our Earth and what happened to it isn't quite over. We've only set the stage for life.